We are back. Time for cyclohexane. Take a seat in your chair. All right. This is a tetrahedral drawing with wedges and dashes that you should be very scared of because I wouldn't want to have to draw that myself. This is the same structure, no wedges and dashes, and I see a lot of things. I see a lot of things that are recurring here. Let's just focus on lines that are parallel and we can go from there. We've got parallel, let's use highlighters and all the colors we can grab. Start at the top. How many lines do you see parallel to that? I see that one. In fact, let's make sure they're parallel. No, maybe not. It was a nice idea. That's definitely parallel to that. But it's also parallel to that and that. And let's go with orange parallel. This is parallel to this, is parallel to this. And even if it's not, it's supposed to be. I hope you're starting to see a pattern of which things are parallel. And let's go with, I don't know, let's go with the baby blue. This is parallel to the thing across the ring from it. Let's use our straightening tool to its advantage. And that. And it's also should be parallel to that and that. These are bonds we're talking about. And every carbon has a bond that's either straight up or straight down. Did you notice that? Straight up here, straight down here, straight down there. There we go, a little better. I'm trying. All right, so let's get our color scheme going on here with a purple action. Let's go this way. Straight up and straight down. Hydrogens are called axial hydrogens. Get your astronomy hats on. In fact, all day we've been talking astronomy terms, haven't we? When we talk about eclipsing, isn't that an astronomy term? So let's continue with the astronomy vein here. So straight up and straight down hydrogens are called axial hydrogens. And if I had my toy, I could put the toy on the table and it would have 3 feet. There's the 3 feet. It would just stand on those feet. Then I could flip it upside down and these would be the feet. You can't use these guys as feet. All other H's are around the outside. They're not up and down. Remember, the axis of the Earth is the imaginary line that goes through the middle of the Earth, straight up and down. Around the middle of the Earth, there's even a country named after that. It's the equator. So I'm just going to say all other H's are equatorial. All other hydrogens are equator. Remember to spell it right. Equatorial. My editor had to correct me so many times when I put equatorial with an I instead of an A. She's a very patient woman. She put up with me. What do we got? We got bold. And we have some orange ones. He's going to let me do this. Come on. Let's move it first. Get in there. I'm still figuring this out. Oh, well. I was going to make some orange and some pink and some blue, but apparently I'm not going to be able to do that. So do you think we can use that as a template for drawing this over again? Here's all the steps. The book has these outlined one by one, but we'll take it from the top. And here we go. And we'll copy each step. So step 1 will be in this color, right? I just moved my screen so it's easier to write on here. Step 1, it'll be in, let's not use purple. Step 1, I'm going to go with a pink. It's a light pink. So step 1. Parallel line about, it's on an angle like this, isn't it? So that represent, hey, not bad for me anyway. There we go. Did that bond. And hey, the other one across the molecule, there you go. So that's step 1. Let's do step 2. I'm going to go step 2 in orange. Step 2, orange. How I like to put that into words is, do you see the 2 inside corners of these sticks that I drew? Inside corners. These are pointing to the outside. I'm going to draw orange, and I'm going to draw it, and it's on an angle. Nothing is ever straight up or straight down for carbons, right? Please, when you're drawing it, nothing is ever straight up or straight down with carbons. The only thing straight up or straight down are these axial H's. So I want an angle downwards, and you will do yourself a favor if you take that and go past halfway. Notice how that's past halfway? It's a little more severe angle than the one up there. I mean, we can get away with that. You don't have to have it exactly like this. And the other one, also from the inside carbon, that's step 2. Step 3, you just finish it off with the blue. Just connect what's not connected with the blue. And go blue. October 23rd. Big news today. Oh, that's step 3. And we're going to go and finish this off. Yeah, I wasn't very careful with that, was I? They should connect. Oh, it was nice to me. Okay. Copy paste, and it should match up here too, shouldn't it? And it did. Pretty darn close. Nice. So that looks pretty much like the one above it. Step 4 should be in purple. Can we just keep going around in a circle here so they're close to each other? Step, I got to be very careful when I do that. Copy, paste. Make sure there's a hand there. Why purple? What type of H's are the ones with the purple highlighted bonds? We got a name for them. The ones that are straight up or straight down. Do you remember? Straight up or straight down? Straight up. And that's kind of short. We can draw them a little bit bigger. That's nice. Drop my pen, but I don't need it for a while. Copy paste. Straight up. Notice every second carbon has a straight up. You want to go back to the original? Straight up on this carbon. Next carbon, no, no, no. One away from that. Straight up. Next carbon, no, no, no. Next one, straight up. Paste. The other carbons where you didn't put the straight up, guess what? Straight down. Paste. Straight down. And paste. Straight down. There you go. And every one of those was a, what kind of hydrogen? I found my pen. It was an axial hydrogen. Axial hydrogen. All right, so I got a hydrogen there. Hydrogen there. Every carbon has an axial hydrogen. Have you figured that out yet? And I'll even tell you, how do you know whether it's up or down? All right, do we have 6? 1, 2, 3, 4, 5, 6. We do. Control T. How do you know? How do you know whether and whether? Wow, that's not even close. And axial H is straight up or straight down? It's a good question. Very good question. It's purple. Oh, I hit the wrong button. Okay. Let me ask you a question. When this carbon meets this carbon, there's the carbon where the bonds meet each other, is that triangle pointing up or down? Answer's up. How did you draw the axial H? Straight up. Move to the next carbon. Is this angle pointing up or down? It's pointing down. Is the axial H up or down? It's straight down. This carbon angle's up. Axial H straight up. Axial H follows the carbon angle, everybody. Here's a down angle, straight down. That's why we did that fourth. Keep loose. There's my pen. Oh. Okay. Fifth. The only thing you haven't drawn, please. Oh, Lord. I have the hand. I'm having a rough time. I gotta use my mouse. That's the secret. Okay. Now my equatorials they have multiple colors. Let's just put them in black. This equatorial H right up here, is it up or down? It's not up. The axial was up. Oh, I haven't told you yet. Every carbon has one bond to an H that's up, and the other one has to be down. Here, the axial's up, equatorial's down. Here, the axial's down, the equatorial's up. Axial up, equatorial down, I could go forever. Well, 6 carbons total. And they're parallel. This blue has to be parallel to these 2 blues. So how do you remember that? Well, the blue is parallel to not the next carbon-carbon bond that's actually attached, but the one away. And that works for this. Not the next one, but the next one. Can I just call that the next? The bond to H is parallel to the carbon-carbon next. The bond to H is parallel to the carbon-carbon next. Ah, I see. So I'm going to do my best. In fact, why don't we do our level best? Should be parallel to this bond here. Oh, yeah. We can draw longer bonds just to make the point. And there's another one. There's 2 blue ones up there. Should have gone with baby blue, I know. But they're normal blue here. And those are H's. We're going to draw equatorial H's last. And see all the blue bonds that are parallel? How about orange? Orange here should be orange here, and then orange here, and then orange here. Just copy paste those oranges. Yeah. Too bad you can't copy paste on tests, huh? Yeah, that's that there. And we got HH. And we haven't done pink yet. We got the two parallel pinks here. We need a parallel in between and a parallel in between. Let's go for it. Yeah, it doesn't lean to the right. It leans to the left. That's a little large, isn't it? Yeah, we're getting the point across. Oh, I didn't copy paste. Thought I was on ChemDraw for a second. Yeah, I have to bring those in. They're just running into stuff. Trying to maintain the parallelness, though. They're still parallel, right? All right. Equatorial H is last. Okay, that is an A. Don't want to get in trouble with my editor. This is a terrible looking U, but live with that. Okay. Nice. Our first chair. Congratulations. 3 out of 3 points. Next up, we're going to put groups on our chair and talk about things. So let's grab this chair here. I think I'm going to get a bunch of extra stuff. Yeah. Oh, well. Why don't we grab extra stuff? And moving on over here. Don't need this comment. And now, this is where I would do a rotation, sigma rotation, because this is the chair per cyclohexane. Before I start putting groups on it, I forgot to mention, this is only half the time the molecules in this chair. And I haven't told you the secret to the chairs. Because of the rotations that we did, the H that is right here straight up is 60 degrees away from this one and 60 degrees, negative 60 from this one. That's perfectly staggered. And every pair of H's in this molecule is perfectly staggered. Not partially eclipsed. No, not fully eclipsed. No, perfectly staggered. As a result, one, what kind of strain are we talking about here? And this is the point in the video. You should pause and say, okay, we had two types of strain. I think he talked about angle strain and torsional strain. Which one is he talking? He's asking me a question. Take advantage of me asking questions, because this is where Zoom is not as good as class, but you can make it as good. Pause, think about the answer. Okay, what I'm looking for is when we have H's staggered with other H's, that means the torsional strain is 0. Okay, and I didn't tell you about the angles. The angle in a flat hexagon, this is clearly not flat, right? But if it was a flat hexagon, the angle's 111. And when we did the sigma rotation to get to a chair, that's what this conformation is called, by the way. And yeah, you have to have a good imagination to see a chair. But when you did the sigma rotation to get into a chair, it went from 111 down to 109.5. So how much angle strain is there? Pause. 0 angle strain, Dr. Whitaker. Unpause. There we go. There's 0 angle strain in cyclohexane. So what's the total strain in cyclohexane? Well, there's no eclipsing, so there's no torsional strain. There's no angle strain whatsoever, so there's no angle strain. Okay, that didn't make sense, but it did make sense, didn't it? Cyclohexane is just as stable as any molecule that doesn't have a ring at all, where there's free rotation around sigma bonds, no restrictions. So that's why we're spending so much time on it. It's very cool. And chair, you're having trouble seeing the chair, huh? Okay, what we're going to do is go back. Sometimes you have to have a little fun on top of your learning. Let's grab the one that doesn't have the H's on it, because that's where we're going to see. Yeah, it's not a normal chair, by the way. Let's put this off to the side somewhere. And let's put boy blue in the chair here. Yeah, here he is. He's sitting in there. He's very content. And his legs are here and here. He doesn't look very comfortable now. And his arms are here and here. I don't know. That doesn't look very good. But he's in a chair. I guess it's a chaise lounge. You know, he's by the pool. And he's enjoying his time reclining in the chair. Okay, so that's why it's called a chair. I still have trouble seeing chair myself. When we go to the other chair, here's the story. We're going to do sigma rotations. And we'll do this going downwards. There we go. It's not a chemical reaction. I don't like using equilibrium arrows, but it's going back and forth like equilibrium. And what happens when you do the sigma rotation? I'm going to pull this bond down to here. And it's going to go, it's going to be like this. It's not bad. And it's going to be parallel to this. And then we need to go, where did we put our next bonds? Was it the inside corner or the outside? Do you remember? Pause. Go back in the video. Oh, he said from the inside corner. Unpause. And here we go. Inside corner on an angle more than halfway to the, that was quite a bit past halfway, but I think it's okay. And you do the same from the other inside angle. Inside corner, sorry. Now we have angles. And then you finish it off here. Thank you. Now remember what I did. To get from this one to this one, I sigma rotated this corner down here. So if we're putting numbers on this molecule, please remember that if you started top right corner for this chair, you'd be making a mistake that's quite costly on your test if you called this also carbon 1. No, you pulled the carbon down to rotate the sigma bond. This is 1 now. I know you could have pulled it down, pulled it over to the left, but if everybody's doing top right going to bottom right, trust me, it makes my job easier grading your test. There's a chair question on the test that takes me about an hour to grade. One question for the whole class. And if everybody's using the same approach, happier teacher. Happier teacher misses a few more little mistakes, forgives them a little bit. Cranky teacher, he's not going to let anything slide. Okay, so what kind of H's did you put on first? Axial H's. I want to point out they're all going to be black this time, because when we did the sigma rotation here, that also rotated this bond down here. So I'll just switch over to black for the, no, I don't have my straightener on, do I? If I do it fast, it didn't work. Do it. Yeah. Sorry, wanted to look nice. There. That's a good one. And that's an H. Good. So I got 3 downward ones. Is this a downward? Oh, paste. Does that go there? No, it does not. Pause yourself and answer your question. Why is that a bad axial H you just did? Does the carbon angle right there point down? It does not. So the axial H should not point down. This carbon angle points down. That's appropriate. This one points. I told myself to use the mouse, right? There's the hand. Now, because things are getting a little tight, I'm gonna bring that up a little. It's still straight down. Shorten it so it's not running into the numbers and things. There we go. And the other H's are straight up, aren't they? The other, oh, that's not very straight up. Hey. Okay, strange stuff's happening. There we go. Yes. Now that arrow's in the way. And move the H down. That works pretty good, huh? Yeah, move that down. So that's everything except for the, what's the type of H I haven't drawn yet? Pause. Go to your previous point in the video. Oh, you haven't drawn the equatorial H's yet. All right, so you're back. I need the H here. It's got to be down. Do you know how I know that? Because the axial was up. It has to be parallel to not this bond, but the next one. Not this bond, but the next one. So I'm just going to do what I was doing before. Copy, paste. Right there. That's good for that one. And if you were paying attention, also this one. Parallel to the same bonds. And over here, I need a down again, parallel to this. Do my best. Do better than my best. Yeah, it's long. There we go. Copy, paste. All right. And how about this one? Now, you know it's not going to be straight up or straight down, right? Because you already did axial, and that was straight up. I'll put H's on the end of these in a second. You know it has to be down, but is it down to the left or down to the right? Well, if it's going to be parallel, it can't be down to the left because that won't be parallel to this. It's going to be down to the right. Here we go. I could copy paste it. Parallel to that means that. Shrink it. Make sure it's still parallel. I'm not sure if it's parallel. Oh, I didn't make it parallel. Oh, yeah, there we go. Copy paste. That goes there too. H's all the way around. Save. Oh, what are we doing? Pen's off. This chair represents cyclohexane half the time, and this chair represents cyclohexane the other half of the time. End of story. Simple story. We're going to do methyl cyclohexane next, and we're going to discover why it spends more time in one chair than the other. But I think we should do that in the next segment. So next segment, we're going to do two things. We're going to do a cyclohexane with a methyl on it. And then after that, we're going to do a cyclohexane with two different groups on it. And we're going to figure out why one conformation is superior or more stable than the other. And I will see you on the other side of this break. And here we go.